Hello everyone. So in this video, I'm just going to give you the solutions to the quiz 1, because most of the questions have been covered in the tutorial sessions. So in this video, I'm just going to give you some quick hints and tips about how to solve these questions. Some of these questions you will notice that because I'm using the function, the quiz function on Canvas, so the system can generate some random number, as you can see here. For example, in question 2, the mass, or the U1, U2, so different students may get different data here. So what I'm trying to say is that I'm just going to use some of these values as one example. So you need to work out your own solutions by the values you have been given. Okay. So the first one, question 1, so I think this one is the same for everyone. So we have three processes. We have a very similar example, I think, in the tutorial. So you can also have a look at the that question in the tutorial 1. I think I can't remember exactly, but you can check. Okay. So here we have 3 processes, and then we know some of these. We know Q, W, U1, U2, and the delta U. Okay, so we just need to find out the missing numbers here. So here we're going to just use, because you can see this is a closed system, right? Closed system, and then we only actually have one equation. So now I'm going to show you the formula sheet. So you can see here, first law of thermodynamics in closed system. So this equation actually establishes a relationship between the heat transfer, work transfer, and the internal energy. Okay, so that's exactly for closed system. We're going to use that. So U2 subtract U1 is what we call the change in internal energy, delta U. Okay, so we're just going to write that. I'm going to copy that equation down here. So that's Q subtract W is equal to U2 subtract U1. Okay, and we'll call this the change in internal energy, which is delta U. So it depends on different values are given in this equation. We will be able to calculate the other 2 unknowns. So for the process A, you can see we just check one by one. Okay, so the first one, 50, has been given, so we can just write inside there 50 subtract W is minus. So you need to be careful, this is minus, because these 2 actually have, both of them have been given, so you actually can calculate it. So 50 subtract minus 20 gives you 70. Okay, this is equal to U2. Okay, just copy that, minus U1, because in this case U1 has been given, U2 has not been given. So it's 25 is equal to delta U. Okay, delta U. Right, so this is for process A. You can see this is 70 equals that, is equal to that. So delta U is actually have been calculated. So delta in this case is 70. Okay, and also U2 subtract 25 is 70, so that you can move minus 25 over there. So you get U2 is equal to 25 at delta U. Okay, delta U is 70, so we've got U2 as 70 plus 25, you have 95 here. Okay, so for the second, so in this case Q is not been given, so this is A. Okay, this is B. So now Q has not been given, subtract W, but W is 40, and the U2 subtract U1. Okay, not U1, subtract U2. So that's 20 subtract 70 again. So both of these has been given, so you can calculate immediately, which is minus 50 is equal to, okay, delta U. So you can see delta U is equal to minus 50. That's why you can put minus 50 here. Okay, and also use the first one. Q subtract 40 is equal to minus 50. And then you'll be able to calculate the Q here. So just move 40 over there. So it's 40 subtract 50. Okay, which gives you minus 10. So I'm going to put a minus 10 here. Right. So again for C, last one. So Q has been given, subject W. Okay, again this is a minus value. Right, so we'll be able to calculate that actually. So positive, negative, you get positive. So that's actually 90 subject 15, which will give you 75. Okay, again U2. The U2 has been given 120. Subtract U1 is equal to delta U. Okay, so you can see 75 is equal to delta U, so that's 75. Okay, and then just going to use that or here to calculate U1. Okay, so that's 120 subtract U1 is equal to 75. So we need to find out U1, right? So you can move U1 over here, you can move 75 over here. So that's 120 subtract 75. Move over there, you get positive. So this will give you 45. So you put 45 here. So that's it for the question 1. Now let's move to question 2. So question 2 here. So we know the mass, right? So the mass is a fixed value, meaning that this is again in a closed system, cylinder. So this is a process. So we know the work is done to the surroundings. Okay, so this is somehow important because when work is done to the surroundings, the value here given should be positive. Okay, should be positive. The gas expands, so we have 2 states, 1 and 2. So here actually I've already this bolded, so this is specific internal energy is given. You can see that unit, okay, unit is kilojoule per kilogram. That again means that's specific values. And also by here, the lowercase u1, lowercase u2, so you need to be careful about all these. So here, calculate the heat transfer. Okay, we're calculating Q. So we know W here. We just need to calculate the Q. Okay, and as I said, the first law of thermodynamics has established a relationship between Q and the W. So we're actually using the same, same equation we used for question 1. So we can write that equation Q substitute W, which is equal to U2 substitute U1. Okay, as you can see here, all these are capital letters. Okay, and this has been given as specific values. We know that any specific value like U is defined by the capital divided by M. Okay, so that you can also write as U, so you move M over there, so that's M times U. Okay, so here you can write U2 there is equal to M times U1. So M are the same, okay? You use lowercase u now, subtract M, U1. Okay, as I said, M is the same, so you can take M out. So finally I get that equation. So now we're just going to put all the values inside there. Subtract W, as I said, W in this case is positive. So M, 4.7 kilogram there. Okay, times U2 is here, 2295, subtract U1, 2077. Okay, and so you just need to calculate, and you can move this one over here. Okay, add 103, then you will be able to calculate Q is 1127.6. okay, kilojoule. So just finally we can do unit to check as well. So W here, so that's in kilojoule. Okay, so this is a kilojoule, and also here these two values are kilojoule per kilogram, but you multiply by a mass which is in kilogram, so you get this kilojoule as well. So kilojoule plus kilojoule, finally this is also in kilojoule, which is exactly requested by the question itself. So it's in unit of kilojoule, so you don't need to do any conversion on that value. So just put that value into the answer box. Right, okay, so this is question 2. So now we have a look at question 3. So question 3 here, so basically it's isobaric. When you see isobaric compression, what does it mean to you? So yes, so the pressure is kept as constant. So we know V1, V2, and then we need to calculate the work transfer during this process, and the answer should be in kilojoule as well. So this is again our formula sheet. So we have 2 equations here, okay? Isobaric, isothermal. So in this case we should use isobaric process, just to use that, because P1 is equal to P2, so we can use any pressure here. We need to be careful. We always use end state, subtract initial state. Okay. So now I'm going to write that equation down. W1 to 2 is equal to P. Okay. V2 subtract V1. So you can see V2, V1 already be given, both in the unit of cubic meter. Okay. So here actually is only one thing you need to be careful, because the equation itself is very simple. So just be careful about how to convert everything to SI base units, so you won't get confused. That's because when we talk about the pressure here, pressure is 4.2 bar, okay? Because bar is not SI base unit, going to times 10 to the power 5, 10, so that we can convert to Pascal, which is SI base unit now. So V2, okay, be careful, as I said, use V2 subtract U1, okay, you can't do this way, the other way, okay, U2, just find carefully, U2 is here, U2 is there, 3.5, subtract 8.8, because this is a small number, so final answer would be a negative value, as you can see. So here, okay, so this is a cubic meter, this is Pascal, both of them are SI base unit, and this will give you a very big number actually. Okay, so this is must be SI base unit as well. Okay, this is a joule. As I said, answer should be in kilojoule, so you need to convert that by divided by 1000, so you get minus 2226 kilojoule. Okay, and then you put that value into the answer box. Right, so that's for question 3, and for the last question here. So you can see all the previous 3 questions are quite straightforward. So the final one will be a little bit more complicated, but we're just going to use quite similar way, because as I said, we have that first law of thermodynamics. So you can use that again. Q subtract W is equal to U2 subtract U1. Okay, because this is a closed system. This is actually the only equation. Okay, only equation we use to describe a closed system in terms of the relationship between, you know, the Q, W, and the U's. So here you need to determine the heat transfer. So we're looking at heat transfer here. Okay, U2, U1. You can see U1 is here, U2 is there. So we're not worrying about these two, so we need to find out W. Right? Okay. So how to calculate W then? 1 to 2. Another set in the formula sheet, we have the calculation of W. We have 2 processes. Okay. So in this case, it's isothermal. Okay. Isothermal, just going to use that equation. Okay. And I'm going to write that down. So this is P1, V1, Ln, V2, subset V1. Okay, if you have a look at the question itself, P1, V1 has been given, V1, and then P2. You can see that there's no V2. Okay, so first of all, we need to find out the V2 first of all, right? So how to find the V2, because we haven't used that for any isothermal process. just a condition here. PV is constant, means that P1 V1 is equal to P2 V2. Okay, so we know P1 V1, we also know P2. Right, so this will, so you can use that to calculate the V2 first of all. So now we can know that we actually need 3 steps for this question. So this is the first one, okay? So this is the second one, this is the third one. So the first step, we need to calculate the V2. V2 is equal to P1 V1 divided by P2. Okay, so P1 is 6.5 bar times V1 divided by P2, 1.5 bar. But this is a division here, okay? So you don't really need to convert them to Pascal, okay? Because the unit will be cancelled, will be deleted anyway. So you don't have to convert in this case, and then you can calculate. This will give you about 1.5257 cubic meter. So now we can calculate the second. Okay, so work done. P1 6.5 bar. As I said again, you need to convert that to. So in this case, in that case, we just said we don't need to conversion because they are division. But in this case, we have to convert to Pascal times V1 V2 over V1. Okay, V2 we just calculate V1. Okay, this will give you 2.6. So this is quite a big number. Okay, so we can actually convert that to kilojoule by dividing by 1000. So now we can do the final step. Q, subtract W, just calculate W. U2, subtract U1, U2 is 850, 500. Okay, this is 350 then. So just move this one over there, so you can calculate the Q. Because these two numbers are in kilojoule, and then we just check this one is in kilojoule as well. Okay, so everything in kilojoule. So the final answer is 626.4 kilojoule, as requested here. The final answer must be kilojoule. So that's the final answer. Okay, so that's all 4 questions in quiz 1.